Hi everyone, welcome to the next video. I hope you all are doing great. In this video, I'll be covering what all are the fixes that Apache team did to fix the two CVs that we talked prior. One is the deserialization bug and the second one is the SQL injection bug. So let's jump right in. The first one is the deserialization bug that we are going to talk about. The bug was basically caused due to insecure deserialization of objects that was sent over a socket. So this is some of what the Apache team or the Log4j team did to fix this bug. So first of all, they completely deleted the SocketNode and the SocketNode class, and they created something called the SocketAppender. So as the name suggests, it's an appender that delivers events, whatever logging events that are there across the TCP or UDP connections. So this code basically entirely is talking about building an event. They are handling the socket options, the SSL configuration, getting the host port, protocol configurations and things like that. So even if it fails, there are things here to say, hey, to reinitiate connections. Now the second thing that they built is something called the TCP socket manager. So this is the one that actually creates the connections. If you think in the prior variant, they had a socket server class for creating the server. Here they have a TCP socket manager. It kind of handles all of it. You can see the port default, socket, and everything. If you see the imports as well, it is importing the INET addresses for the IPv4 or v6 addresses, socket for creating the socket. I guess they are also importing thread, log4j thread, and things like that. Serializable and a lot of the layout classes and things like that. So basically this is the class that is going to be handling most of the creation and rechecking if the connections are present or not. And you can see the constructs that they are giving, like the output stream, the socket, the internet address of the host, name of the host, port, and things like that. So they have different constructs for creating these connections. So all of these are defined here. Uh, and yeah, they are getting the get socket manager layout. You are actually providing a config.properties file, right? So it's going to be looking into all of that, whether all the required informations are there or not. But I haven't still discussed how they fixed the bug though. Like the bug was a deserialization bug. So how they got rid of that is that they completely moved away from Java object stream um, to something called JSON. So JSON objects, if you're not familiar, are uh, used all over the place, all over the internet for sending and receiving data. So most of the data inside of that will be in the text format. So it won't be actual Java class or objects. So then we move to another file that is called JSON layout. This is kind of deprecated. The newer one that is the JSON template layout. But I'll just go through this thing as well. So when you are actually writing in the config properties, you can actually mention JSON layout or JSON template layout or whatever you want. So what happens here is that whatever information that you want, the log, everything will be JSONized. It will be in the form of application slash J in JSON format, and whatever you need, it will return that as an object to the TCP socket manager, and that is the one that will send it out over the network and you will receive it, thereby completely eliminating the deserialization attack. See, object message as a JSON object, So it's a really nice way of protecting against deserialization attack. So this is basically what they have done. So major files to look at is JSON layout, abstract socket manager. It's a small file that extends the output stream manager. That's about the output stream. You need an output stream to send data as bytes out, right? So but this is only getting the getting the host and getting the port and some of those informations and the content format as well. Main files to look at are the JSON template layout. That is a new thing that is there. That is the one that is actually creating all of the logs into the JSON object. And go through this file particularly, and the SocketNode and the TCP socket manager. So these are the main things to look for to understand how they fix the bug in the latest Log4j 2 variants. I think this is running 2.3.4.4. That is the version that I'm having right now. And this doesn't have any of those Java objects, any of that. So they completely moved to JSON. And the second bug, but yeah, before I do that, right, I just want to show you the config.properties, how it might look like in this thing. So you can see the root logger level is info. We're using SocketAppender, localhost, port number. We are using the JSON layout, and this is kind of how it will look like. Yeah, so this is a drastic change from the previous config properties where you're actually putting in your you are using socket server for it. Yeah, but this is how it changed out. Now the next one is the JDBC thing. So there was an SQL injection present in the JDBC thing. The crux of the vulnerability is that instead of treating code and data differently, the previous Log4j version was treating the entire thing as code. So you can actually send in SQL code as in the config properties file. So how they fixed is that they completely they separated the entire code and data as separate there, so they're treating code differently and data differently. So any of the logs that are coming in are treated as data and not as code. So that is being done by a few of the files. First thing is that they still have the JDBCAppender, but it has been highly modified for this thing. In this case, okay, so the JDBCAppender kind of is giving all of its tasks to JDBC database manager. There was no such file prior. There was only a JDBCAppender previously. In the JDBC database manager, it actually handles all of the database connections and things like that. All of the relational database accessing by JDBC is handled by this thing, this file particularly here, and you can see, so what does that mean though for the security? It means the JDBC data manager will be taking in data from the logs, and it will be using prepared statements for see, it's using Java SQL prepared statement. So it will be using prepared statements for storing the value. So prepared statements actually is like a placeholder. So you will have your query preset, and whatever data that is gonna come into it will be will be converted into a string and put into that particular part. So it won't create any SQL injection vulnerability per se. So that is how they are doing it. Here you can see some of the insert values parameter for column mapping, things like that. So that's how they're doing it here, and they're also doing one level of checking further on that. They have a prior to this there was no column mapping in the database thing, so you can send in whatever you want. So here you have a column mapping and a column config particularly for a table where you are inserting your log into. So they are a config. So this one is the column config file. So it's actually used to configure which event properties are logged. So specifying if only three properties needs to be logged, it will only log those three properties, and if you're adding anything extra or anything, it will say, hey, I cannot accept that. The properties only accept for these many events. And we have a column mapping as well for, this is actually for specifying, a database column name, for mapping the layout and things like that. So that's how they kind of negated the attack vector of SQL injection by really checking the input that is coming in, checking the database as well, having a proper database manager file so that any input, any logging input is treated as data instead of code, and finally everything flows through JDBCAppender as a parent. So that is kind of how they solved all of this. You can see some of the layouting in the column mapping and things like that. To write to database and things like that. Uh, they are using literals, layouts, and things. So think of it like, your timestamp will be treated different, your message will be treated different, and your context will be treated differently. If you don't understand what these all are, you can go back to my previous video on JDBC and the server socket for knowing what the actual bug is. Then you can get more context on this. So that's it. That is how Log4j team actually fix both of the vulnerabilities in this version. Um, yeah, so this has been a significant change in how they handle most of the database handling, uh, as well as the deserialization bugs. So we completely phased out the Java objects per se and moved to JSON as well. Anyway, thanks for watching, guys. I hope you liked the video. I'll be creating more videos like this in the next week or in the coming weeks. Why am I limiting that? Thank you all so much for watching. Bye.